Good morning, good afternoon. 안녕하세요. Jacques Gourmelon from French Nucleus Pig Genetic Company and Carolina Garcia, geneticist at Nucleus Company. We are pleased to present you today two small presentations concerning one, the genetic progress and all the efforts done in Nucleus concerning the genetic activity, and from my side, one case report in farm. So we will let Carolina do his own presentation, and I will do after my presentation. So please, Carolina, goes on.
Thank you very much, Jack. I will share my screen with you in order to share the presentation as well. Okay, so to start with, good morning or good afternoon, everyone. My name is Carolina Garcia Bacino. So first of all, I just wanted to show you this first slide, in which the main idea is to show you that our work in genetics guarantees success from the farm to the plate. Okay, so now officially I will present myself. My name is Carolina Garcia Bacino. I am working as a geneticist in Nucleus. I have a master degree and a PhD degree in animal breeding with focus in genetics and genomics from the University of Buenos Aires, Argentina, from where I am from. Today, I will speak of what we are currently working on in Nucleus with special focus in genetics. So first of all, I will present you the global strategy of Nucleus, the main aspects of it. So as you can see, there are basically four. So to start with, I will start on top in the violet one with the measurements and data collection. This is a step that is very important because working with large quantities of high quality data guarantees success. Second, speaking of quality, we perform a control of data quality and we monitor this aspect systematically to ensure a good quality of the data, as I mentioned. We take into account as a third step this data to carry out genetic evaluations that enables us to select the animals objectively according to the traits of interest. And finally, the fourth one, we constantly monitor the genetic progress in all of our lines. So, speaking of genetic progress, in this slide, we can see a plot for genetic progress for large white, considering two traits. So you have in red the number of born alive piglets per liter per year, and in blue we have the number of weaned piglets per liter per year. As you can see in the x-axis down in the bottom, we have the year. We consider here a period of 5 years. And in the y-axis, we have the genetic value. So we can see a consistent increase of the genetic merit along the years for both traits. As you can see in red, for the number of born alive, we have an increase of 0.3 per liter per year. And for the number of weaned per liter per year, that's in blue, we have an increase of 0.27 per year. So two main ideas that we have to bear in mind from this slide is first that we have a gain of approximately 1.5 piglets born and weaned in 5 years. And since 2017, all piglets born should be weaned. Okay, in the same fashion as the previous slide, here we have the genetic progress for the number of functional teats in large white still. As you can see, we have a positive genetic progress also, increasing the number of teats at a rate of 0.05 functional teats per year. And it's important to mention as well that the large white population of Darby in South Korea has actually a mean of 16.8 functional teats per tested yields. In the same fashion as previous slides, here we have the genetic progress of number of born alive piglets per liter per year in blue, and we have the number of weaned piglets per liter per year that's in red, in blue, it's the number of weaned piglets, and in red, the number of born alive. And in both cases, it's 4 landrace. So similar to the large white, we have a gain of approximately 1.5 piglets born and weaned in 5 years. And since 2017, piglets born should be weaned. Here we have the genetic progress of the number of functional teats in landrace this time. As you can see, we have also a positive genetic progress, increasing at a rate of 0.06 functional teats per year. And it is important to mention in this case that the Nucleus landrace population has actually a mean of 16.1 functional teats per tested gilt. So, considering the breeding objectives in female lines, we take into account different traits and give them different weights. As you can see in the slide, we grouped them using different colors. So, we have first in yellow, the number of born alive piglets with a weight of 31% in the breeding objective. Then we have in orange, the mortality rate in piglets with a weight of 13%. Following that, we have in red the percentage of small piglets, that is to say those that weigh less than 1 kilogram. And this trait has a weight of 12% in the breeding objective. Then in violet, we have the consumption index with a weight of 23%. Just to be clear here, when we speak about consumption index, we are speaking of the ratio between the quantity of feed ingested and the weight gain of the animal. And finally, in blue, we have the meat quality and conformation traits with a weight of 21%, as you can see in the slide. As you can see, these traits are also important. The meat quality and conformation ones are also important in female lines, as we will see in the next slide. So, in summary, what is our vision regarding on how to work on selection on female lines? Okay, so here are 2 main points to focus on to answer this question. First one is the piglet quality is very important. We take into account the weight at birth and at weaning as well, and also the litter size and homogeneity since birth. And second, another idea we have to bear in mind that it's important as well is that 50% of the production performance, that is, for example, to say consumption index, carcass, etc., of a terminal pig is given by the mother. That is why it is important to include these traits in the breeding objective of female lines as well. So, going a little deeper into birth weight and weaning weight, we have another question. And that question is why? Why it is important to measure these traits and work on them? Well, first of all, we have to take into account that the increasing prolificacy has an impact on the number and weight of piglets born and also the number of animals weaned. Second, it is important to work on the ability of sows to feed and raise a large number of piglets correctly. In terms of concrete results, we have been working and making important progress in order to have autonomous sows, for example. Basically, these sows are sows that can take care of their piglets with minimum human intervention. And this involves aspects related to behavior, maternal quality, and, for example, having also an adequate or optimal number of teats. These aspects are very important, and we have been doing important progress or improvements on them, as I have already shown in previous slides. And of course, we continue to work on these aspects. And also an important idea is that collecting individual weaning weights at 21 days allows us to study the interest of this trait at an individual level, for example, analyzing average daily gain, and also at the sow level, for example, working on litter weight gain, milk production, etc. Okay, so what we have in this slide, we have some pictures of the moments in which piglets are weighted, just as an example. So on the left, we can see the moments in which the piglets are weighted at birth. The picture was taken during some training and during an interesting exchange with a colleague from South Korea here in France. And just to mention that in the last 8 years, we recorded approximately 500,000 birth weights. On the right, we have a picture of the moment in which the animals are weighted at weaning. Just to give you an idea, in the last year, we collected around 50,000 weaning weights at 21 days of age. Okay, and the following question is, what do we do with all this information that we collect? Well, we carry out different analyses. Here, for example, we have a graph in which we can see the distribution of the complete litter weight at weaning in female lines. So you can see on the x-axis that we have complete litter weight. And we can see that in red, we have the distribution for large weights, and in blue for landrace. We can see that there is variability in the distribution, and this is very interesting because this means we are able to continue improving in this trait. Variability in this context, it's a source of genetic progress, and it means that we can continue working on this trait and making progress still. Okay, and what about robustness? Okay, so first of all, it is important to clearly define what we are talking about when we refer to robustness. And here is the basic idea we have to bear in mind. Robustness is the maintenance of a production performance level, health and well-being in a wide variety of environmental conditions to which animals are exposed to. We want a robust animal that can cope with changing conditions, producing at good levels, let's say having good performance. So, how do we take robustness into account when selecting our pigs? Okay, we consider the animals as a whole, and we work on all aspects that directly or indirectly contribute to robustness, such as the breeding performance, considering things like prolificacy, breeding career or longevity. Also, production performance of the offspring, taking into account, for example, the birth weight and its variability, among others that are also shown and detailed in the slide. It's important to mention that we also consider the ability of the animal to cope with health challenges and its ability to adapt to heat stress. And for example, leg structure, it's also important and taken into account. We have actually several ongoing projects related to this topic. And okay, how do we do this? Well, we collect data on all these aspects and combine them to select robust animals. Working with broader selection indexes enables us to consider many traits together when selecting animals, and in this way, keeping the most robust ones. We are also working, that's important to mention, on the development of methods that help identifying animals with optimal responses to environmental challenges. And in this slide, we have two examples of concrete things that were achieved during the last years, thanks to our work on robustness, and of course, things that we continue doing in this regard. So first, on top, we have a picture of a product that is produced by Coperl, that is a major actor in the French pig markets and a major stakeholder of Nucleus. Coperl is actually producing 500,000 antibiotic-free pigs since birth per year. These are animals that can cope better with infections, for example, so they are more robust animals. And on the other picture on the bottom, you can see a selection farm in China with 1,600 selection sows. This enables us to evaluate animals in different conditions regarding the environment and the breeding environment regarding different aspects. And this enables us to select those animals that are more robust. Okay, and what about meat quality? Well, this is also a very important aspect for us as well. We collect routine continuous measurements of pH, for example, that are measured at 6 hours and 24 hours after slaughter at 2 places on the carcass, as you can see on the picture on the top right. The 2 places are shown with black arrows. Then we also collect information of drip loss between 24 and 72 hours after slaughter. This is measured on a sample of the loin, as you can see on the picture at the right. And we also collect information related to intramuscular fat on sire lines. So going a little further in the intramuscular fat measurements, we have to mention that this trait is correlated with meat tenderness and flavor. That is why it is important to measure it and work over it. This trait is taken into account in the selection goals of Nucleus male lines, and the intramuscular fat is estimated in vivo by ultrasound images analysis. Basically, we analyzed 6 images per animal, and this is done by a Canadian partner, that is the CCSI, that is the Canadian Center for Swine Improvement. And just to give you an idea, in the last 7 years, we collected information on the intramuscular fat for more than 10,000 direct animals. And as you can see in the pictures at the bottom of the slide, there is, the moment in which the ultrasound is done and the resulting image on the right. Regarding meat quality, when we go to numbers, if we speak about female lines, we observe an improvement at the phenotypic level in both large whites and landrans. Drip losses are reduced at a rate of approximately 0.19 or 0.17% per year, which represents a gain of approximately 1.8 euros per carcass in 5 years. And just to mention a little about other important traits to consider when selecting, we have longevity. Basically is given by the length of an animal productive life. Longevity is a trait with low to moderate heritability, that is going from 0.08 to 0.20. When we speak of heritability, basically, we refer to a measure of how easily a trait is passed on genetically. The higher the heritability, the easier the selection on that trait. In this case, having values higher than 0 means that we can select for this trait and make progress. There's also an important idea here that there is a link with, for example, structure traits, like, for example, leg structure. So to wrap up, I would like to go through some important ideas. In the previous slides, I showed you how we work in Nucleus, making focus in the main ideas and main results of the genetic aspects. Basically, the idea I want to go through now is that working in genetics implies anticipating future demands, working for the long term, of course, investing in new technologies, and measuring phenotypes accurately for many traits of interest. We have been working on these aspects for many years now, and we will continue on this path, aiming at continuous innovation. So basically, the idea, in a few words, is to have beautiful, heavy, and homogeneous piglets always. So with this, I would like to thank you for your attention, and we will be happy to answer if you have any questions. Thank you very much. And now I will let Jack continue with the second presentation. Thank you.